Okay, so we've got sine 0.7 is equal to 0.644. Cosine, that's the same angle, 0.7. The cosine of that angle is 0.765. And then the same angle again, but for tan 0.7 is equal to 0.842. Alright, so we're going to work out what these are. And they look funny, don't they? They look funny because we've got a decimal there, we've got decimals here. We don't have any of our special angles, we don't have any of our special values like root 2 on 2 or root 3 on 2. So it looks a bit funny, but really there's nothing complicated about this chapter. So, first of all, let's have a look at our unit circle. What angle in radians is that?
Pi.
It's pi, or 3.14 approximately. Okay? So that means that 1 radian is somewhere around there. And 2 radians would be about here, and 3 radians would be about there. And then, what's this distance? What angle is that? That would be the 0.14 radians, right? And just as a recap, 1 radian is approximately, sorry, what is that? 1 radian is approximately how many degrees? 57.29 degrees. Okay,
Do we need to remember that?
yeah, you need to know that.
Okay.
So for questions like this, you have a reference point. Okay, it makes sense. So when it says sine 0.7, we're talking in radians here. Okay, there's no degrees indicated. They could ask you for 0.7 degrees, in which case they have to indicate the degrees. If there's no degrees, we're talking radians. So 0.7 is about 7/10 of this angle. All right. So let's draw that. Somewhere around there. Okay, so let's say that's 0.7 radians. Okay, and then we have a coordinate here, and the sine of that coordinate is 0.644. Okay, the cosine of that angle is 0.765. Does that look reasonable? According to the diagram, it's biased to the cosine. The cosine is longer, it's past the halfway mark, and so therefore the sine is shorter. And then the tan of this angle would be, the tan of the same angle would be the slope.
Yeah.
Okay? Excellent. We have a reference point now. So what is sine 2.442? Well, 2 radians is somewhere around here. Okay, now they're not asking us to use a calculator, they're asking us to use symmetry. Right? Anyone could just type in the sine inverse of that and work out what the value is. Sorry, not the sine inverse, but the sine of that. We could type it in. In fact, let's just do that. Type in sine 2.442. Make sure your calculators are in radians, and let's find out what the value is.
0.64.
644. How did I know that? Because it's right there. Because they want us to use symmetry. So 0.644 is our value. Okay? So basically there's a symmetry happening from first quadrant into second quadrant. First quadrant into second quadrant. So basically 2.442 is the same as sine pi subtract 0.7.
Yeah.
True? And since we're in the second quadrant, the y values are the same because of our reflection. So therefore, we're going to use that answer, 0.644. Okay? So let's write this in terms of pi. That's going to be pi plus 0.7. True? So which quadrant are we in this time? We're in the third quadrant. It's pi plus that angle theta. And so if the cosine was 0.765, what do you think the cosine value is there?
Negative.
It's going to be the negative, isn't
Yeah.
it? So this is the negative 0.765. Good. Now let's do the tan. Tan 0.7 has a gradient just under 1, so this end value is 0.842. And tan 5.584, that is perhaps just less than, just under, what am I thinking, 2 pi, that's right, 6.28,
Yeah.
right? So this would be tan 2 pi, 6.28, subtract 0.7.
So in the fourth quadrant.
Yeah, so we'd be in the fourth quadrant. So let's draw the reflection over the x-axis. It's going to look like that. So it's the negative slope of that value,
Yeah.
which is negative 0.842. Yeah? Looks tricky, looks complicated, but really everything about this chapter is fairly simple.